We are going to be talking about a match fit process. To start out, we're going to give you a little overview on Ada Technologies. We're in Ada, Ohio. Our parent company is Asumitech out of Japan. We actually started production in 1997. We've been on Plex for around 3 years now, and we are a Tier 1 supplier to Honda. This is just a look at some of the parts that we make. We generally make internal transmission parts for Honda. We also have some plastic injection molding parts, as well as some shifters that we do. We've got some reverse shift forks, some balancing drums, a few different parts there. What is a match fit? It's an assembly's BOM component, may vary based on its mating with another BOM component that has some variable tolerances. We actually have a couple different areas at Ada Technologies that has this match fit process. Our business situation is we have an assembly work center where all the BOM components are assembled together to make one shaft assembly. During this assembly, we have a possibility of using one of 5 different, what we call a stopper, to use based on the diameter of the shaft which is fitted on. The shaft assemblies are packaged into finished good containers at the work center. Our customer is not concerned with which stopper is put in the part as long as we only have the one customer part number issued. And the customer supplies our stoppers based on our orders, so this works nicely with MRP as well. Let me see if I can get this. It's not going to work for me. These are our stoppers that we have. Like I said, there's one of 5 different types of stoppers that can be used, and we know which stopper to use based on how it's being fitted on the line. And then this is just a glance at our process here. The parts are put into a quality machine, and it tells us the tolerances of the stoppers that we need. So while they're in process, they're deciding if they need stopper 1, 2, 3, 4, or 5. And then they package them into a finished good container, and they palletize them all at one customer part number, regardless of what stopper was used in the process. Okay, we'll let Marty handle the technical side.
Thanks, Karen. Actually, I have to hand it to Karen. She was volunteered for this
Yes, that's why he's here with me.
She actually didn't go through the trials and tribulations of this to begin with. One of her cohorts was responsible for this process. So as you saw on that last slide, there are actually 5 different parts because of their bill of materials in one container, and the customer considers it one part number. But for ATI's purposes, the question is that one internal part or is that 5 internal parts? So that was really kind of the decisions that we had to make, and we had to test different Plex solutions to come up with the ultimate answer. So if you consider one internal part number, one thing we looked at was, okay, can we adjust the job BOM for this so that we are changing the stopper bill of material for the run, but we don't have a steady stream of tolerance of the shaft. It varied greatly, so they were constantly changing back and forth with the different stoppers that they needed. So then we went down the route of exploring variable bill of materials. So with that variable bill of materials, we can call out that each part takes 5 stoppers, but sometimes you have one stopper for one of the stopper part numbers, or you have 0 for the other part numbers. So that's really typically that variable bill of materials more used in, say, a blending process or in a food and beverage process where you have ingredients. So that forces you to go through a batch processing screen. So that is, it was not real intuitive for the operators, so we discounted that. So then we decided to go down the road of, okay, this really is 5 different internal part numbers. So how are we going to handle this? Well, The standard simplified Kanban bin for bin, that all proved to be too slow because we didn't want to have to constantly change the job setup to be able to reflect the new part number that we're producing on the line. Also, one of their requirements is they needed full traceability because it was important to them with every part to know what stopper was mated with that shaft. They needed inventory accuracy, so it had to decrement properly to keep inventory correct. And of course, they needed to order these components, so they needed to send forecasts and releases for these, and those had to be accurate.
There you go.
So the solution we finally settled on was to create one generic internal part number that included all of the 5 stoppers. What we did then is based on the typical distribution of tolerances of the shaft, we had a distribution of what stoppers were used on those shafts. So with that generic part number we had, say for example, the most commonly used stopper was stopper number 3 was at 50%. Stopper number 2 and 4 were at 20%, and stopper 1 and 5 were at 5% to give us that our distribution of usage on that one generic part number. We then mated that with the customer part number so that all of the releases flowed in on the generic part. We then created 5 different internal part numbers, each having only one designated stopper. We set those, though, that they all had the same customer part number as the generic part number, but again, the releases only flowed in on the generic. We would then schedule 5 different jobs, one for each of the part stopper combinations. And to start off with, we were only using an MRP net demand. Then as we moved to job demand, we set the job types on each of these 5 part stopper combinations to be not flagged as MRP. So net demand would flow down through. So then we made the work center type eligible for multi-jobs, which is also known as dynamic multi-outs. And this way, the operator loads all 5 jobs at one time, so he has 5 different output containers available to record production in. So Karen, if you go on, this will show you a representation up here. This is the generic part with the 5 different combinations, and you can see in the quantity usage, it's a percentage of one stopper for each of those based on the normal distribution. Below, you can see one of the 5 parts, which has one stopper being referenced. Those are where we actually schedule the jobs, are on those parts. So this is what the operator sees. The operator sees the dynamic multi-outs. They've loaded 5 jobs. They have 5 different output containers. Each one of these represents a shaft stopper combination, and they can quickly record production into one of those output containers without changing the job setups. So it's a much quicker process for them. So as they're going to recording production, and that is properly decrementing the right container. Then if you look at the MRP, you will see that the demand is flowing through as net demand off of the bill of material of the generic part, and it is properly forecasting the usage by the 5 different stoppers. So that allows them to order correctly. You want to talk about the benefits?
You're doing great. I'm doing good with this pointer.
So as far as the benefits go, of course, recording production is very fast for the operators. It's very intuitive. It doesn't require the frequent setup changes. The recorded production in scrap, it correctly decrements the correct source container, so that gives them accurate inventory and also true traceability back to the stopper. Container label formats coming out of that process are all the correct customer part number labels. So even though you may have a container that has truly 5 different internal part numbers, they're all labeled as one customer part. And of course, their MRP recommendations are based on that net demand, and they are adequate for component ordering.
The button's on the bottom, maybe hit it, or maybe your battery dies.
I think your battery's gone.
Oh, great.
Perfect timing.
Yeah.
So I'll open it up now for any questions anyone may have. Yes.
On the output containers, you have 5 unique serial numbers.
So the output containers, we have one customer part number,
Yeah,
but each one of those has 5 different.
So at the end of the job, if you have 5 partial containers, the customer just carries one full container. Do you merge those, or how do you?
Yeah, it's possible we can merge those. Correct. Yes.
Maybe a little unrelated, but we've had Honda pushing for us to get a system in place to uniquely identify each piece.
Yes.
Are you having to deal with that at all?
Serialized individuals, actually, they do have a process that's going to be requiring that very soon. So Plex has a number of ways to handle that depending on what the requirements are.
So you can scan the serial number on the piece and know what's in this container? and-
Yeah, so you can scan
Correct.
the serial number to the piece. It's called an option 3 as far as Plex goes. You scan that serial number to the container, and it validates that it's a unique serial number, so it has not been referenced with any containers previously. And as you're scanning that to the container, it properly increments the quantity in the container. Any other questions? Thank you very much.
Thank you. Thank you.